hopefully you understand that an inverse function is a function that undoes a function. Okay, so it's like a very basic function could be 10x, so multiplying something by 10, and the inverse of that would be to divide by 10. So they undo each other. So in practice, all we have to do is swap x and y, and then rearrange to make y the subject again. Okay, so you might want to note that inverse means it undoes something. Now, we do have special symbols, so the inverse symbol is -1. Okay, so the inverse of f of x would be with that little -1. So that's the symbol. It's worth noting that if you put f of x inside the inverse, they will cancel each other to just get x. Same thing if you did it the opposite way. Okay, so they undo each other so that you're just left with x. The key thing that we need to learn today is if it is a quadratic, you're going to need to complete the square. So inversing a quadratic, you'll need to complete the square. Hopefully it makes sense as to why we would need to do that. If we look at the example I've got here, this is a quadratic. Okay, it's missing a number at the end. But if I switch, straight away, make that x and y squared and minus 2y, you can see that straight away I have two y's and I need to make y the subject. So how can I make y the subject if there are two of them? And this is where it's really helpful to complete the square, because when you complete the square, you remove that extra y. So let's just have a go at that. So remember, with completing the square, you halve that number and subtract that number squared. Okay, so you can see straight away I've gone from 2 y's to just 1. And now I can inverse it. So I can add that on, so x plus 1. I can square root that. And then lastly, I can just add that 1 over. So it's going to be this 1 equals y. Now, some of you might be sitting there thinking, hang on, she didn't do plus or minus root x. The reason I didn't is because of this. If you're looking at the positive side of things, you're only going to have the positive square root. And if it had been less than, you'd just have the negative square root. These are the little details that will give you A stars. If none of that makes sense right now, that is fine. That's something that I work on a lot closer to the time of the exams. At the moment, we're focusing on the bulk of the marks, which is just learning to actually inverse the function. Okay, the next example I've chosen because it's like a really good example of what you'll actually get in the exam. So there's a whole lot of questions here, and they're all to do with everything that we've been learning. Okay, so that's what they're going to do. So you will notice we have a quadratic. Now I have actually drawn it over here, or at least the computer has. There's a couple of things I want you to notice. First of all, you can see the terminology. They'll do f of x with that weird arrow. They've also done what we call restricting the domain again. So they've restricted the domain to just be a section. So I haven't done that on my picture, so we'll do that now. So this graph actually only exists between 0 and 3. So that means, if I just use the highlighter, that the graph is only this section. Okay, the rest of it is gone. So none of that actually is existing. Okay, they're just looking at that graph just between those two values. So the first thing they've asked us to do is complete the square. So hopefully we're getting awfully good at that. So halve that number, subtract that number squared, and drop the 2 down. X minus 3 squared, and that's minus 7. So hopefully that marries with what we've got here. We're expecting the vertex to be at 3 and -7, which is what we've got here. State the range of f. Whenever they say state, that usually means you don't have to do any work. The information should be basically there. So normally the range would be just y is greater than or equal to -7, right, from the vertex up. But they have restricted it, so it stops here, okay, and it stops at the y-intercept. The y-intercept is always this number here at the end. So the range of f is from -7 up to 2. Okay, so the range is where can it possibly be on the y-axis? So it's essentially just giving that range. The domain of the inverse. Now, this is really cool because it sounds really tricky, but the range of f is just what it is in terms of y. And we know that an inverse is just swapping x and y. So it's literally all I have to do is change this to x because it's for the inverse. So the inverse, if you want to know the domain or range of the inverse, you just work it out from the range and domain of the original, and you just swap the x and y's around. So if I want the domain, I'll do the range of the original. So I'm going to write -7x 2. If I want to write the, oh, it hasn't asked for the other one. That's cool. If they'd asked for the range of the inverse, that would be this one, and we'll just do y is between 0 and 3. Okay, so they're literally just opposites of each other. I'm just going to write that up here. So domain of the inverse will equal the range, and the range of the inverse will equal the domain. Right, lastly, we want to find, well, not lastly, find an expression for the inverse. So again, we're using our completed square form. So I'm going to put x is equal, I'm using this expression here, y minus 3 squared minus 7. I'm going to add the 7 over. I'm going to square root it. And this time I'm actually taking the left-hand side, so it's going to be the negative, and adding the 3 over. So again, don't worry about the details too much about whether it's plus or minus. If you're not sure, just put plus, and we'll work on that way closer to the end of the year when we're working with the details. It is my cat meowing. Right, I'm probably going to skip that one because it's just taking quite a long time. This is a really common question if they want you to sketch it and make clear the relationship between the graphs. So it's a 3-mark question. It is just a sketch, and you just have to kind of give a rough idea of what it looks like. So I'm going to show you what the sketch would look like rather than my beautiful, well, I don't know if you'd call it a beautiful picture, but the actual graphing of the function over here. So what you would normally do is draw the original. We know it crosses at 2, and we know it goes down to 3, -7. And then we just label that as f of x. Now, the relationship between the graphs. They reflect in the y equals x axis. Because that makes sense, right? Because they're switching y and x. So they just flip that over. So I always draw the mirror line first. This is worth a mark, drawing it and labeling it. And then you draw the other one. The other one is just a complete reflection, which means it's, oh, this is a terrible drawing, but that went down to 3, 7. So this one's going to go up to -7, 3, and it's going to cross at 2 here. So like something like that. Again, it's a sketch. They don't care. You label it like that. 1 mark, 2 mark relationship. Okay, so